Hi, welcome to Teardown Tuesday. Let's take a look at an interesting meter. I've actually had this one for a long time. You've probably seen me use it in the odd video here and there, but I haven't got around to doing a teardown of it. Let's have a look. Thank you very much, Keysight, for sending this one in. It is the rather interesting U1461A. It looks like a regular multimeter, and it is a regular multimeter, but it's also a mega tester, hence the big test button here, and anywhere from 50 volts up to 1,000 volts. So it's got that mega functionality built in, which not many meters on the market do. So fantastic. It's got an OLED display. There are other models in this series which have an LCD display, and I won't turn it on to show you because that'll violate my rule of turning it on before taking it apart. But suffice it to say that, yeah, the OLED is really nice indoors, but you try and use them outdoors and they're pretty crap, and they chew battery and things like that. Not as bad as some of their previous series meters that have actually done this, but yeah, still, they've got an LCD version, but it does not have the full multimeter functionality like this one has, and it's actually a very impressive multimeter, like 0.09%, and it goes down to, it's a 60,000 count display, or 66,000 I think, and it goes down to a 6 microamp range on the current, so it really is quite a nice meter. And it is, here it is, where is it, IP67, so it's waterproof, it's drop proof, super rugged meter, and well, it's a real nice bit of kit. About 900, just a smidgen over $900 US street price for this puppy, but I believe it does come with the hard case, and it comes with the Bluetooth adapter as well. Why they can't build this into their meters, I don't know. Comes with the infrared USB cable. Comes with all sorts of probe accessories and oh yeah, regular cow stuff. But it also comes with a remote probe as well. Hence why you'll notice that it's got a little extra interface like that, so that you can actually get a switch. You'll see there's actually a switch on top of that, and you can actually take samples or whatever with that, and that actually plugs into here, and you'll see there's an extra connector down inside there. I'm not necessarily a big fan of that, well, on a general purpose meter. If you have a need for that, then that's, you know, an awesome function, of course. You don't have to touch the meter. You've got the button right there on the end of the probe to sample that. But yeah, for a general purpose meter, I don't know, I just don't like the look of having connectors in there. But anyway, this is a beast of a meter. So, you know what we say here on the EEVblog, don't turn it on, take it apart. I don't have my screwdriver right to hand, so I'm going to give it a thumb. Let's go. And it's just like the one I've looked at before, the U1462A, Keysight's new rugged multimeter, and I've beat the crap out of one of these. Click here if you haven't seen the video. I've beaten the crap out of this thing. It's basically looks like exactly the same thing, and it wouldn't surprise me if all the housing and everything else is exactly the same. But these are like real big meters. Take a look. That's compared to the EEVblog meter. I mean, that's like, yeah, these things are not great for just general purpose, you know, use around the bench, in my opinion. They're just like really big and just take up a lot of room. I much prefer a real small compact meter like the BM235, just for, you know, general purpose meter on your bench, just for, you know, measuring your basic stuff and things like that. This puppy is designed for industrial field use. You know, it's big, it's rugged, and it's going to do the business. Just like this one, I have no doubt it's going to be just as rugged, just as waterproof as this baby. Wow, check out that serial number. Like 1 with the digits in front. I wonder if I got the first unit. I don't know. I probably had it for that long. I may have. But yeah, it's exactly like the other one. It's got the absolute winning case design, if I can get that off there. Fantastic for the fuses, and the batteries down here uses 4 AA's, and they've got these rubber surrounds on here, which are just absolutely brilliant. So they've definitely used the same case, because look, they haven't got the extra fuse in here for the 10 amp range like they did on the other one. And well, it's a dead giveaway because they don't actually have a 10 amp jack on here. They've only got microamps and milliamps. So you know, if you're into high current stuff, then it's going to be no good, which is a bit unusual for a big industrial meter like this, if you buy this as a 1 meter does everything, then yeah, that could be a showstopper. But anyway, let's go. You can see some diodes down in there. And I'm not sure if it ordinarily comes with the lithium batteries, but if it does, oh, winner chicken dinner. I mean, these things are just awesome. They're not cheap, but geez, if you want the ultimate performance from any AA or AAA battery power product, then that's definitely the way to go. All right, let's lift the lid, and ta-da! We're in like Flynn. We've only got our one cable here, and I do believe it's exactly the same as the previous one in terms of, as I said, like same housing and everything. You'd have to review the video to see. We've got some shielding up there, but woo, here we go. Ooh, there is our magic transformer that generates the high voltage. Bingo. I wonder why the top of the common jack there is purple. What's going on there? I'm not sure what that is. Weird. Anyway, the front end is, apart from the 10 amp jack, which is in here, it's all, standard fare. This is 600 volts Cat 4. It's going to do the business. As Keysight would have designed this, and it looks very nice. We've got 2 thymistors here with the heat shrink on there to stop them, exploding violently. We've got a couple of gas discharge tubes down here. Neat. And we've got our requisite ceramic input resistor down here, shielded, or ceramic input divider. Whatever it is, our main input cap, we've got our diode protection, and not a huge amount extra on the input. And we saw this contact arrangement on the U1462A, so I won't go through details on that one again. Okay, it's Tegano microscope time. Let's check this puppy out, and we can zoom in on various things. We've seen the front end. There was no a 1K input protection resistors like we saw on the 1282A, but yeah, I guess they don't need it for whatever requirements they've got. Looks like we've got ourselves a poly switch down in there. That's nice. Let's have a look at the main chipset. It'll be no surprises for guessing that it's exactly the same. And yep, it's the Hycon HY3131. I'm very intimately familiar with this puppy, and you might see why in the future. And it's a nice chipset, by the way. It's worth looking at the datasheet for this thing. If I haven't mentioned it before, it does have lots of info on how all the input switching and configuration and stuff like that works. It's really a good datasheet. Anyway, oh, we're missing a little 5-pin SOT23 there. And MELF, gotta love the MELF. Just throw it in for good measure. No worries whatsoever. Soldering looks good. No issues at all that I can see. And what else have we got? 052, that'd be a TL052 op amp, would be my guess. It's not, doesn't have to do anything critical. So cells, that'll be a low dropout regulator, 1117 or something like that. 053, that'd be a 4053 analog switch. Really old school, 4000 series CMOS vintage. Got ourselves a bunch of TANTs. Another TL05 or a TL052 Mux. And here we've got ourselves a Max 4583. That's a analog switch, and once again, like a probably better performance specs than just your 405, your 4000 series CMOS muxes and things like that. And bingo, we have ourselves the analog devices 8436. Putting it, I don't want to have it upside down. All the electrons will fall out. There we go. That's your true RMS converter, of course. If I put it straight down, as I said, hard to see, depending on the angle of the lights and things like that. It can be hard to read the code, but you get them at the right angle, and look at that. Sticks out like a dog's hind leg. But here's what we want to see. We want to see how they're generating the high voltage, because all the other stuff is just, multimeter stuff we've seen in the U1282A teardown, so check that out if you want to see more details of that. You can clearly see, look, an analog ground split here, complete ground split. It only joins, looks like it only joins through there, but apart from that, it looks like there's a clear split in there. So, yep, they've only joined it at one point. So you don't want any, you want all your current flowing back to the one star point effectively. So they know what they're doing. And the main processor is going to be on under here, 9.83 meg. I can't remember if that's what the other meter was running at or not. Don't even remember what processor. Geez, I don't know. I don't do any prep work for these. I don't watch my own teardowns. Anyway, we've got ourselves the isolation transformer. That's our custom high voltage isolation transformer. And it looks fairly typical of what you'd find in a mega teardown. In fact, I've done a Uni-T. I think it is a Uni-T mega teardown. I'll have to probably link that video in at the end of this, actually. For those who are interested, that's, you know, very substantially different to this, whole different construction and everything else. But yeah, I'm surprised that that's all she wrote there. When I was about to say, like, where's our voltage multiplier? But aha, I thought these were resistors here. These are actually diodes. So bingo, there we go. Look at the cascaded configuration like that. That is our high voltage multiplier right there. And that would be a Cockcroft-Walton voltage multiplier. I've done a Fundamentals Friday video on that, so click here to actually watch that. I've done a tutorial and demo on how these voltage multipliers work. So that's just interesting. I expected to see like huge clearances and everything else, but no. And all of this would be at the same level, so they don't need it. So that was interesting to see if there's anything else on the other side. What we've got there is that would just be a switching controller, 28135. Aha, the game changes when you get it out of the case here. There we go, there's our input protection resistors that we I think they were on the top side in the previous build. Anyway, so another big beefy diode in there, check that out, another one. Beautiful. And yeah, very similar to the 1282A, I think. Oh, a bit of residue left there. They've hand soldered, somebody's hand soldered that one. So anyway, there's our OLED display. Brass standoffs, thank you very much for playing. Awesome. And that's of course its own module. It's got all its own driver stuff on there. The main processor under there. But let's have a look at the micro that we've got here. Might have to give that a tilt. There we go, the 78F 1168A. That is different to what's used in the 1282A. That was, I think, a lower model one. So this is an NEC 16-bit micro, not very common in an instrument like this, but nonetheless a popular enough chipset. There's the external E² prom. So yeah, maybe they need to do more stuff. They needed a bigger one in there. We've got a header for our OLED module, and that's about all she wrote. Bob's your uncle. Once again, we've got some hand soldering residue here, but aha, I was talking about the lack of clearance on the top side here. Well, here's all our clearance is. This is where all our high voltage stuff pops out, and you got massive, you know, millimeters and millimeters of clearance here. Looks like we've got ourselves a UTC MOSFET down there. That'd be to switch the output off and on. Of course, that'd be our output switching MOSFET. So when you press that test button, that's what dumps it in. So there you go. That's all she wrote. They didn't need a huge amount for the high voltage section. I thought maybe they might have put it on a separate PCB in an isolated block or whatever, but they've actually done the engineering to put it onto the main PCB. So hats off to that. That makes it cheaper and easier to implement. But yeah, potentially more spins to get it right, perhaps at the engineering stage. But once you've done that, then no worries whatsoever. So that's how they're doing it. It's nothing special. It's exactly what I expected, actually, on the high voltage side. Just the physical implementation was maybe a bit different. I wasn't expecting it to be integrated onto the main board there, but I guess it makes sense in the case. They had to reuse the existing case, so that would have driven their design decision to choose to put it on the one board, because they like physically mounted it. I guess they could have mounted it like headers, but then you've got the OLED module on there, and oh, that's a bit messy. What's going on there? Hello? That's messy business. It's designed to be there. Like that's a slither of ground plane going through there, but that's a bit how you're doing. Not that impressed with that at all. Anyway, minor little thing apart from an otherwise very nicely assembled unit. So anyway, did I finish my sentence there before I was rudely interrupted by C79 down there? Yeah, this would have driven their design decisions to mount it, to design it all onto the one board and not have a separate thing, because, physically mounting it could have been a real pain in the butt. So, have they got some sort of sensing happening on there? Looks like it. And for you OLED module fanboys, there it is. Nothing special. It's just got its own voltage driving circuitry. And we've got, as is common, chip on flex down there. That is actually the silicon. They flip it over and you can see all of the traces. That's not just one fat trace. There we go. We zoom right in. Let's go. No, these are all the different, these are the traces coming in. That the flat flex is soldered onto the board there, but these are all the output traces. Vroom, around there. Count them all. Go for it, and you can probably count how many rows and columns we got. Wah, 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 wah. Agilent Technologies. None of this Keysight rubbish. And I do like the nice little header that they've got there. And the top half of the case, exactly the same as the other one. Look at the previous video if you want some more commentary on that. All right, let's see if this puppy still works, shall we? Hopefully it does. Yep, Keysight. It doesn't say Agilent. That'd be old firmware. Anyway, yep. Well, let's, generate 50 volts. Nah, let's go all the way up to 1,000. No worries. Hello? There we go. That's better. 1,000 volts. And greater than 260 gig. That's what you'd expect. The flicker on the display, you can't see that in real life. That's only visible on the camera. That's a function of the frame rate of the camera. In fact, I can play around with the frame rate. And that's 1/2000th of a second frame rate on my camera. You can't see it too well. That's 1/1000th of a second. And that's 1/500th of a second. Getting there. 1/250th of a second. That's 1/120th of a second. And we're slowly getting there. And yes, by the way, it kind of does look that dull, but because I've got like all my studio lights turned on here, it's going to start to wash it out. And 1/50th of a second, we're almost there. 1/25th of a second, you can still see, actually you can still see it pulsating at 1/12th of a second, and you'll see my finger here. Yeah, that's at 1/12th of a second. The frame rate's not high enough for my finger not to be a blur. So I've really got to get down to my lowest frame rate on this camera, 1/6 of a second, to see this. And if I bring my finger in here, slow motion. That's hilarious. But yeah, that's the annoying thing about filming OLED and CRT displays and things like that. And I can show you this test probe. It's still got Agilent on it. Check it out. Brilliant. Well done marketing. I guess they can't toss them all out. And yeah, it's got the switch on here, and that activates the test functionality. So it's got the extra jack on there. Plug that in, and watch this. Hello? Helps if I plug it in properly. Dope. There we go. And it goes into test mode and generates the 1,000 volts. No worries whatsoever. And this is one of the adapters that comes with it. That's a shrouded banana plug, so you can plug it straight in. So that's actually rather neat. And it comes with, of course, all the other stuff. So actually, I need to do that. And then we can plug in the big alligator clip. Look at that. Fantastic. Or crocodile clip, whatever you want to call it. Probably should call it crocodile clip, considering I'm a bloody Aussie. And we've got a standard multimeter probe, and it looks like we have another one, which is shrouded all the way right down to the tip, so that'd be, Cat 4 compatible. So, yeah, we can just plug that straight into there like that. Look at that. Multimeter probe. Neat. Ooh, 1,000 volts now. No touchy. So there you have it. That's a Keysight U1461A multimeter / insulation tester, Mega, whatever you want to call it. Mega's actually a brand name. Who owns that now? Is it Danaher? Owns Mega? I'm not sure. Anyway, it is quite neat because you can go from 50 right down to 50 volts. It's got different settings all the way up to 1,000 volts. Mega. It's got the probe interface, which could be, be really nice for stuff like that. And what does it do there? That's just the hold functionality on there. So there you go. And as I said, it can go down to it's got a 6 microamp range on the thing too. Very impressive. The only thing it lacks from a multimeter point of view is amps range capability. So it can only go up to 600 odd milliamps on the milliamp range, I believe. So I believe there's only one other meter in the same category as this, and what it's designed to completely compete against is the Fluke 1587 FC, the new Fluke Connect model with all their, they're standardized all the wireless functionality across all their meters. And that one's actually cheaper than this though. The Fluke one's about, I think it's even $720 street price, although like $800. This one's just over $900 US, of course, but it depends on where you get it from. But yeah, the OLED display, I don't know, it's like they're nice. OLED displays are very nice, but they chew more power and outdoors. And as you can see, like viewing that is pretty terrible. Like I can't see that from here. I'm standing behind the camera and I'm probably getting maybe as good a view as you are on that LCD. I mean, it is not great at all. And yeah, I don't know. They have the same model with the LCD display, but it doesn't have a lot of the multimeter functionality. So I don't get it. I don't get what they're doing there. There must be some build reason behind it. I don't know. I haven't done a teardown on the other one. Anyway, it is very nicely built and designed and built as you'd expect. It's a Keysight, so you wouldn't expect any issues, but it really is quite a versatile instrument if you're in the market for something like that. So anyway, I hope you like that. If you did, please give it a big thumbs up. As always, links down below. High-res teardown photos, link down below as well. As I do most of my teardowns, I take high-res photos as I go along, so you can read chip details and things like that. And click here, as I said, if you want to see the teardown for the 1282A multimeter, and also I've done a Uni-T teardown, I think it is, of a Mega, and that is a totally different construction because it goes up to like 5,000 volts, I think it is. So it's it's much different in its design and construction in terms of clearances and things like that. Very substantially different. Well worth checking out that for what it takes to design a Mega that goes up to 5,000 volts instead of 1,000 volts like this one. You can get away with it on the one board. You can't do that in the other one. Anyway, hope you like that. Catch you next time. Hi. What happens when you apply 5,000 volts across the range switch of a cheap-ass multimeter? I'm glad you asked. That bit of fun and frivolity came from this puppy, which is a Uni-T UT513 insulation tester. Maximum range, 5,000 volts here.